This is lesson 5.3. We're going to do example B now. The previous videos, part 1 and 1.5, were examples A. Took a little bit longer because we did table of values. In this example here, what we're going to do is we are going to do a mapping rule rather than a table of values, but I would recommend you practice both methods. So let's take a look at our function here in the vertex form. We have a few different pieces of information. The first is we have our A value over here. So we know that because we have our A value, that's going to mean, so A value is going to mean our first transformation is going to be A is equal to 1/2. This is a vertical compression. By half. That means it's going up half as fast, or 2 times slower. The next thing we want to look at, the next key points, are the H and the K. So we have our H over here. So that's our second transformation. H is equal to -5. And what that means is we have a horizontal translation to the left by 5 units. So horizontal translation to the left by 5 units. And then we also have our H over here. So our H, or our K, sorry. So this is our H in here. Our K is over here. Our K is -9. So that's a vertical translation down 9 units. And so again, we're going to start off by plotting our y is equal to x squared and label that. So y is equal to x squared. We know at 0 it's 0. Again, you can use the table of values. At 1 it's 1. At -1 it's 1. At 1 it's 1. At -2 it's 4, because y is equal to x squared. -2 squared is 4. At 2 it's 4. At 3 we have 9. The -3 we have 9, so 4, 5, 6, 7, 8, 9. Again, I'm going up by units of 1. You would label that to make sure you remember you're going up by units of 1 as well. And then also at 3 over here we have 9. And so we can go and connect these dots to make our y is equal to x squared parabola. And remember, this extends upwards as well. So here we have y is equal to x squared. So we can make a mapping rule to figure out the other coordinates. Mapping rule. And so we know that y is equal to x squared has coordinates x, y. And so what we can do is we can write down a rule for what the coordinates of this function is going to be compared to y is equal to x squared. We know, first of all, that there's going to be a horizontal translation. A translation to the left by 5 units. So our x values will be moving to the left by 5. So x minus 5 would be our new x values. And our y values, there's a few things happening to them. So the compression or stretch applies to the y value. So we know that our y value is going to be multiplied by half. But in addition to that y value being multiplied by half, there's also the translation going down. So we're also going to take 9 away. And so you can use this mapping rule to transform any of the coordinates from the y is equal to x squared function into a coordinate from the y is equal to half x plus 5 squared minus 9 function. So I'm going to show you an example of that to give you the final parabola. But remember, the goal of this question is to graph all of the parabolas, starting with compressions, then going to translations. But I'm going to show you how the mapping rule can help you to get to the final parabola, and then we'll go in and draw in that intermediate one after. So let's go take a look at a coordinate on the y is equal to x squared graph. Let's take a look at 0, 0. 0, 0 over here. So that would be 0, 0 on y is equal to x squared. But if we apply our mapping rule, then what that becomes is 0 minus 5, which is negative 5. And then our y is, so half times 0 is 0, minus 9. So minus 5, minus 9. So now we can go 1, 2, 3, 4, 5. That's minus 5, and then minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our 0, 0 became minus 5, minus 9. Let's do that with another point. Let's do the point negative 1, 1. So if we had negative 1, 1, and we applied our transformations, to negative 1 you would take away 5, so that would become negative 6. And then our y value, first you multiply by half, so that's 0.5 minus 9. That's minus 8.5. And so you would have negative 6, 1, 2, 3, 4. Here's our x value here. So we move over 5, so 1, 2, 3, 4, 5, so we're at negative 6 now. And then we'd move to negative 8, and then 0.5 here. Negative 8.5. Let's take a look at our 1, 1. So for 1, 1, it would be a similar idea. We would take away 5 from the x value, so it would become negative 4. 1 minus 5 is negative 4. To our y value, we would multiply that by half, so half minus 9, negative 8.5. So that was this point over here. We count 5 units to the left, 1, 2, 3, 4, 5, which is negative 4. And then we go down 9. We go down by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then don't forget that we had to multiply that y by half first. So that's why we got negative 8.5 over here. And then we can do the same thing with some other points. So let's look at the point over here. We have the point negative 2, 4. So negative 2, 4, let's write that down. So first, our negative 2, we're going to take away 5, so it's going to be negative 7 now. So negative 7. Our 4, we have to multiply it by half, so it becomes 2 minus 9, negative 7. So this point here becomes negative 7, negative 7. Just to show you, we're moving over 5, so 1, 2, 3, 4, 5. So that's negative 7. And I'm moving down 9. Or we're multiplying by a half first, and then moving down 9. So we now have negative 7 as our next coordinate here, which is right over here. If we did the same thing with we can do the same thing with the 2, 4 coordinate. So first to the 2, we're taking away 5, so that becomes negative 3, because that's our x value. The 4 times half is 2. The 4 times half is 2. minus 9 is negative 7. So we have negative 3, negative 7. So this one here is moving over 1, 2, 3, 4, 5. That's negative 3. And then we're going to the negative 7 over here. And we can do the same thing with our points negative 3, 9. So if we have negative 3, 9, to the negative 3 we are adding 5. We are taking away 5, so that becomes negative 8. The 9 we're halving it, so that becomes 4.5 minus 9, so that becomes minus 4.5. So we have negative 8 minus 4.5 as our next coordinate. So 1, 2, 3, 4, 5, 6, 7, 8 over here. And then minus 4.5, 1, 2, 3, 4.5 right here. And you can do the same thing with the coordinate 3, 9. So by the same token, the 3 take away 5 would become negative 2. The 9 would also be minus 4.5. It's symmetrical. So we have negative 2, 4.5. So negative 2 over here. And then 1, 2, 3, 4, and then 0.5 over here. Then you can connect your dots, and you get a parabola that's wider than y is equal to x squared, also lower and shifted to the right 5 units. So this would be the y is equal to half x plus 5 squared minus 9. Again, I just did the mapping rule, so I just took the y is equal to x squared and did all the transformations at once using that mapping rule. In reality, for a question like this, though, I'd want to see all your graphs. So at first I'd want to see your compression alone, then I'd want to see your translations. So if we're doing compression alone and you wanted the mapping rule for the compression, rather than doing the mapping rule all at once, the mapping rule for the compression alone would be like this. You would have your xy for the y is equal to x squared. But for the compression, you'd have x half y. So I'll make that a different color here. Let's do red. So half y. So for every x, my y would go up by half. So my 0, 0 is fine, because 0 times half is just 0. But let's go to 1, 1. This would be 1 over, and then half times my 1 y there would be 0.5. So this would be over here. Then negative 1, 1. So 1 times half is 0.5. Then for my 2 and 4 here, my x would be the same, but my y would be half that. So here I'd have 2. And then for my 2 over here, my negative 2 and 4 here would be negative 2 and 2. So notice that was a compression because my parabola became wider. And so here we'd have y is equal to half x squared. And then the translation would follow. I did my horizontal and vertical translation together, which is my final mapping rule over here. So in reality, you'd start off with y is equal to x squared. You would then do your compression mapping rule, and then your final mapping rule would be your minus 5, and then your minus 9 to apply the h and the k values respectively. And so that was multiple translations done using a mapping rule instead of a table of values. I recommend that you try this out. The work here was a little bit sloppy the way I proceeded. You would make sure that yours is nice and organized. Organize a little area in your page where you're going to show your mapping rule being applied to each point. So for example, you would have your xy coordinate for your y squared, and then you would show your xy coordinates for your compression, followed by your translations. In the next video, we're going to do another example together using mapping rules and or table of values based on your preference.